Humans first walked on the moon in 1969, and since then we haven't gone any further. Is that about to change? The US, Russian, and Chinese government space agencies have all stated plans to send humans to Mars in the future, and there are several companies making plans too, including Elon Musk's SpaceX, Jeff Bezos' Blue Origin, and a few startups like Relativity Space and Impulse Space. Would you live on Mars if you had the chance? If you did, you'd probably want to be sure that you had enough energy to power a comfortable lifestyle, given that the natural conditions on Mars are not that accommodating. A question that I get asked surprisingly often is whether the energy for that could come from wind power. This got me thinking about what a wind turbine on Mars would look like compared to Earth wind turbines. So in this video, I'm going to show you what changes we'd need to make to an Earth wind turbine to get it to work with Martian wind. And we'll talk about what the other options are to power a human settlement on Mars and whether wind is likely to be one of the better options. I'm Rosie Barnes. Welcome to Engineering with Rosie. With so many companies and governments making plans to put people on Mars, I assume that we're going to go there eventually. I guess the big question that comes to mind now is why? Why on Earth would anyone choose to leave this nice planet with its breathable air, drinkable water, and generally pleasant temperatures for Mars? A planet with a thin CO2 atmosphere, no liquid water, and an average temperature of minus 60 degrees Celsius. Sure, Mars is the most Earth-like planet in our solar system, but it hasn't been custom-made to human needs, or to put that more accurately, humans haven't been custom-made to Martian conditions, and it would be really expensive to get there. Each of the organizations working on Mars missions have put forward reasons why: scientific exploration of the planet, technological advancement, commercial opportunities through resource extraction or space tourism. But I think the real reason is more honestly articulated by Elon Musk, who said, "You want to wake up in the morning and think the future is going to be great." And that's what being a spacefaring civilization is all about. I can't think of anything more exciting than going out there and being among the stars. In summary, it's cool. And no one wants someone else to be the first to do this really cool thing. Realistically, that was the essence of the space race that put humans on the moon in 1969. It's FOMO, scaled up as far as billionaires or government budgets will allow. Okay, so let's assume that humans will eventually try to live on another planet. And if we're going to do that, then Mars is for sure the most likely candidate. It's the most Earth-like planet in our solar system, with a similar length of day and temperatures that are not that far off Earth's, with 20 degrees Celsius near the equator during summer, though it does drop to negative 125 degrees at the poles in winter. But it doesn't have liquid water. Its atmosphere is thin and it's mostly carbon dioxide, and Mars' gravity is only 38% of Earth's. There's also dust devils there, which are storms similar to Earth's tornadoes, and they have planet-wide dust storms that can last for several months. There are other planets that are far more hospitable, but not in our solar system. The most Earth-like that's been found so far is Kepler 452b, but it's 1800 light years away. Mars, on the other hand, can be reached in about 6 months, depending on the trajectory taken. A round trip would probably take about 21 months and include a 3-month stay on Mars to wait for the planets to realign correctly again. That's less than the longest duration that a human has already spent in space, so it's not totally infeasible. Just getting humans to Mars, however, is not the extent of the problem. Once we're there, we're going to need a bunch of stuff to survive. Breathable air, water, food, shelter, a way to travel around on Mars, and hopefully also a means to get home again. All of that can be either brought to Mars ahead of time, or it can be made there, if there is enough energy to do so. And it's that energy that's the topic of this video. If you're interested in learning more about space, then Brilliant.org is the perfect resource to help you do just that. They are the sponsor of today's video. Brilliant.org brings STEM concepts like math, science, and computer science to life through a visual and interactive approach, which helps the concepts stick because you learn by doing, not just by memorizing. Whether you're a student, educator, or technology enthusiast, Brilliant offers thousands of topics to explore, with new content added every month. If you want to learn more about the physics of outer space, then I suggest you check out Brilliant's many lessons under the astrophysics course, which features lessons like Goldilocks Zone, where you can learn about why water can't exist as a liquid on Mars, or the lesson on exoplanets to learn about planets outside of our solar system. That could potentially be humanity's next stop after Mars. To try everything Brilliant has to offer, free, for a full 30 days, visit brilliant.org/engineeringwithrosie or click on the link in the description. The first 200 of you will get 20% off Brilliant's annual premium subscription. Until now, power needs in space have typically been met by solar power. In fact, the first solar-powered satellite was in 1958, decades before solar was cheap enough for Earth. Early solar power in space provided the motivation and funding for the research and development needed to create a more efficient and cheaper solar panel, which is now used to generate power here on Earth. Other energy technologies that have been used in space include fuel cells and nuclear power in the form of radioisotope thermoelectric generators, or RTGs, which have been used since the Apollo missions to the moon. These generators produce electricity through radioactive decay, using the heat generated as a power source instead of splitting atoms like traditional reactors do. Each of these options have been used on Mars already, but none at the scale that could power a human settlement. The Mars rover's power needs are in the range of 100 watts plus or minus, whereas a human settlement on Mars would need tens of kilowatts or more, depending on how self-sufficient they're trying to be in terms of growing their own food, manufacturing construction materials, or producing chemicals. NASA is developing a nuclear fission reactor called Kilopower that could be used on Mars. The aim is to produce a smaller, lighter, longer-lasting and safer version of the normal fission reactors that we use on Earth. The Kilopower reactors will generate 10 kilowatts for years without refueling at a mass of about 1.5 tons. Solar panels will also need to be modified to work effectively on Mars due to its relatively dim sunlight and dusty atmosphere. They'll need to use multi-junction photovoltaic cells using multiple layers tuned to Mars-specific frequencies to capture as much energy as possible. And because it's so dusty, they'll need to be specially coated so that a dust layer doesn't settle and block out the sun entirely. Solar panels that could produce 10 kilowatts on average could weigh somewhere around 10 tons, depending where on Mars you put them. Plus, they'll need storage for overnight power needs and to cover the months-long dust storms. So nuclear and solar are two options to power a Mars settlement. What about wind? Never before has wind power been used in space. But then there is no wind on the moon or the International Space Station because there's no atmosphere. Mars does have an atmosphere, and in fact NASA has already flown a helicopter there, the Ingenuity, which hitched a ride to Mars on the Perseverance rover. If Mars air is thick enough to fly a helicopter, then it should be thick enough to run a wind turbine. But how well would that work, and is it practical? Let's take a look at the conditions on Mars and how we'd need to alter an Earth wind turbine to get the same amount of power on Mars. The power generated by a wind turbine is calculated using this equation. CP is the wind turbine efficiency, and there's no reason why that should be any different on Mars than it is on Earth. Rho is air density, and on Mars, air is only 1/60th as dense as it is on Earth. So all else being equal, we'd need 60 Mars wind turbines to generate the same power as a single Earth one. And then the next term in the equation is V cubed. That's the wind speed. And because power depends on the cube of the wind speed, just slightly faster wind gives a lot more power. So if the wind on Mars is 4 times faster than the wind on Earth, then a single Mars turbine would be equivalent to an Earth one despite the low air density. The final term, A, is area. Instead of having 60 wind turbines to get 60 times the area, we could also make a turbine with blades about 8 times as long to sweep an equivalent area. This might not be as crazy as it sounds. Since there's less gravity on Mars, structures do have the possibility of being much larger than on Earth. So there's a couple of questions I want to answer here. Are the wind speeds on Mars much faster than on Earth? And if not, could we make a wind turbine with blades long enough to generate the same power as an Earth wind turbine, or would we need a large fleet of small ones instead? Wind speeds on Mars are actually not that well known yet. We only have a few measurements taken by some of the rovers that have landed on Mars. And based on that, a really good site might hope to reach 10 meters per second on average. To put that in comparison, that's the same as a Class 1 wind site on Earth. So there's not really much difference between Earth and Mars wind. Now let's see how we'd have to modify the Mars wind turbine to generate the same power as an Earth one. We're going to use the same equations as I did in the video I made on how big wind turbines can get, which simplifies a wind turbine blade to a thin-walled cylindrical beam. Our Mars blades are 8 times as long as our Earth blades, and we're keeping everything else the same. An 8 times longer blade has 8 times higher stress, so to make sure that the blades don't break, we could triple the diameter, which makes the mass 24 times the original blade. But then this theoretical blade would also bend 3 times as much as its Earth counterpart, so to reduce that, we'll have to make the blade out of a stiffer material. Earth turbines are designed to make electricity as cheaply as possible, but there's nothing cheap about a Mars mission, so we don't need to use the same fiberglass that most Earth wind turbine blades are made out of. We can use more expensive carbon fiber, which is about 5 times stiffer. So if we change the material, we can get a Mars blade that bends the same amount as the Earth blade, and bonus, it's also stronger and lighter. And if we really wanted to make this super long-bladed wind turbine on Mars, we could use an even stiffer, even more expensive material, like something using carbon nanotubes. There are plenty of practical problems with this hypothetical wind turbine though. So let's assume it's going to be a 10 kilowatt wind turbine, which is a very small turbine on Earth, but in the rough order of what people are estimating we'll need for the first Mars settlement. On Earth, that would weigh a little over 500 kilos and probably power like a small farm. The tower and generator mass should be similar between the two versions of the turbine, but instead of 3.5 meter long blades like on Earth, our Mars turbine is going to have 28 meter long blades. And if they're made of carbon fiber, they'll weigh about 18 times as much as the short fiberglass Earth blade, so perhaps as much much as 2 or 3 tons all up just to power this pretty teeny wind turbine. Let's assume that we could say halve that by using high-tech and expensive materials. That's still at least a ton, and it seems unlikely that they're going to want to send over a ton of wind turbine when they could just send over a 1.5-ton nuclear reactor that can be sited anywhere and produces predictable power output regardless of the season and dust storms. And that's not even taking into account how hard it would be to try and find space to fit the 28-metre long blades. I don't think our hypothetical Mars wind turbine is going to be the first power generation we send to Mars. But the nuclear reactor would be really tricky to refuel on Mars. It would probably be easier to just send it from Earth. But sending constant care packages from Earth isn't exactly in the spirit of space colonization. If there's going to be a self-sustaining Mars settlement, then eventually they'll have to be making their own stuff using local materials. And for that, wind power could be a candidate. There's plenty of iron in the Martian soil to make steel, or concrete known as Marscrete can be made from Martian regolith, which is a mixture of soil, rock fragments, dust, and cured with sulfur. It's surprisingly strong and could be used to 3D print habitats and potentially wind turbine towers. Making either of these materials locally would be energy intensive though, and then we might find that we're making the steel to make the wind turbine, to make the energy to make the steel. It's a bit of a chicken and egg problem. Would the components for the first wind turbines need to come from Earth then? In that case, the mass becomes really important, and we're going to want energy generation that has a high output per kilogram. And a good candidate for that might be airborne wind. That's a technology that I covered in my most recent video. Plus, I followed that up with a live stream on the topic with Dr. Roland Schmel from TU Delft. In fact, it has already occurred to a research group under Roland's supervision that Mars might be just the place for airborne wind, and they have developed a proposal for combined airborne wind, solar and storage system to power a human settlement on Mars. They've planned a 10 kilowatt system with most of the energy coming from an 80 kilowatt rated kite generator, which weighs only around 280 kilos. So way lighter than either the conventional wind turbine, solar panels, or the nuclear reactor. Its low mass compared to the conventional wind turbine we designed earlier is because it doesn't need a tower, and the kite in this system is filled with Mars air and so very light. It also benefits from the fact that it can reach faster wind speeds that are found high above the ground. The TU Delft team's system also includes 70 square metres of dual-axis solar panels for secondary energy, weighing a little over 120 kilos. For storage, they've included 120 kilos of lithium-sulfur batteries for day-to-day storage and compressed air energy storage for seasonal storage that weighs 1.4 tonnes all up. Airborne wind isn't a mature technology on Earth yet. The most advanced systems still need a human operator and assistant on site to help launch, land, and respond to unpredictable gusts. So that might make it sound like a risky bet for a manned Mars mission, but I don't think that's a reason to rule it out. Space travel has always required new technologies to be developed, and there is a very long list of technologies that we rely on now on Earth that originally needed space missions' big budgets to get them working. These range from insulin pumps to smoke detectors. Perhaps a space mission will provide the opportunity to take airborne wind on Earth to the mainstream, just like it did for solar power back in the day. So I don't think that conventional wind power will be the choice to power the very first manned mission to Mars. It won't make sense until humans need to stay there for a long time and be self-sufficient and want to do a lot of energy-intensive activities there. But when that happens, wind could make a lot of sense to use in combination with other generation and storage technologies, much like it does on Earth. Thank you to the Engineering with Rosie Patreon team for supporting this and every video I make. If you'd like to join us, there's a link in the description. We've got a Patreon-only Discord server where we chat all things related to the energy transition and give ideas for future videos. And thanks to you all for watching. I'll see you in the next video.